Hello, and welcome to your video on solving inequalities. As we go through the steps for solving inequalities, you're going to find that they very closely mirror the steps that we use to solve equations. The difference is with an inequality, we have symbols like greater than, less than, greater than or equal to, or less than or equal to, instead of an equal sign. So let's get started on your notes. The first step that we want to do is to take care of distributing. There are two cases where you need to distribute. The first is if we have parentheses in the equation. So if you're looking down at the examples in your notes, number 4, on the right-hand side of that inequality, we have parentheses. So that would be a case where we need to distribute. And the second possibility where we need to distribute is if we would like to clear out the fractions. So looking at number 2, that has a fraction in it, we would need to distribute with that problem. The second thing we want to look for is to possibly combine like terms. Just remember that this can only happen when those like terms are on the same side of the equation. After we've distributed and combined like terms, the next step is to move all of the variables to the left side. Now, it didn't matter so much when we were solving equations, but with inequalities, we want to make sure that the variable is on the left side, because if you recall from the notes on the introduction to inequalities, order does matter. We're eventually going to be graphing our solutions, and if the variable is not first, you can get a little bit mixed up with your graphing. After we've gotten all the variables together, the next thing that we want to do is to undo addition and subtraction. And what I mean by that is just to use opposite operations. So if there's addition in the inequality, we would use subtraction to solve it. And then our last step is to undo multiplication and division. And here's where you need to remember your special rule. If you multiply or divide, like we did in our investigation, if you multiply or divide by a negative number, you need to flip the inequality. And that only happens if you multiply or divide by a negative. It doesn't mean if you get a negative answer, you flip it. It just means if you multiply both sides by a negative number. So let's get started on some examples. Our first example is a two-step equation. So we don't have to distribute or combine like terms or even get all the variables to one side. There's very little work to do for this one. So we're going to begin by adding 1 to both sides, just like we did for equations. We bring down the 6x, the 1's cancel, and we bring down our inequality symbol. So the greater than symbol is going to stay there. We add the numbers to get 42. Next, we're going to divide by 6. And I divided by a positive number, so I do not need to apply the special rule. So I am left with x is greater than 7. Now, you're going to be asked to graph your solutions. So you can typically put your endpoint in the middle of your number line. That's fine. And you can number every line if you'd like. You can go every other line, whatever makes the most sense to you. So I've labeled some points on the number line. And then if you recall from our lesson yesterday, we are going to have an open circle because it does not include 7. So I'll graph an open circle at 7. And then we want numbers that are greater than 7. So numbers that are bigger, which means we're going to be shading to the right. So I should be shading this side. So numbers that are in the solution set would be 8, 9, 10, 10 and a half, 10 and 3/4, any number that is bigger than 7. Our next example was the one I had pointed out with the fraction. So we are going to look to distribute here. And if you recall, we want to multiply by the common denominator. And in this case, we have just one denominator, and that's 3. So I'm going to multiply by 3. What we need to make sure that we do is multiply every single term by 3. Make sure you get the constants in addition to the fractions. So 14 times 3 gives us 42. We keep the symbol. And notice I don't have to flip it because I didn't multiply by a negative. I simply multiplied by a positive 3, so everything's going to stay the same. 3 times 2 is 6. Divided by 3 is 2. So I'm left with 2y. And then finally, 6 times 3 gives us 18. So now I've basically gotten the inequality back to one that we just solved, just a two-stepper here. So we're going to get rid of the 18, subtract 18 on both sides. So these are going to cancel each other. 42 minus 18 is 24. Bring down the inequality symbol. Bring down the 2y. Now we need to divide both sides by 2. Again, we divided by a positive number, which doesn't change anything. So 24 divided by 2 is 12. Bring down the greater than or equal symbol, and then bring down the y. But think back to your notes. Order matters. And right now, we have our variable on the right-hand side of the inequality. So what we want to make sure that we do is we just want to read that backward. Understand that this is not flipping the inequality. So it's not applying our special rule. We did nothing with negative numbers. We're just simply reading it backward. So we're going in this direction. And so our answer then would be y is less than or equal to 12. So thinking back, the less than or equal symbol is a closed circle. So as I start to label some endpoints here, I'm going to put 12 in the middle, and I'm just going to go every other for this one. So I'm just going to label the even numbers just to save a little time. The endpoint is 12, and it is included, so we fill that in. And then we want to shade less than, numbers that are smaller, so we have to go to the left. So we're going to be shading in this area. Again, I mentioned it in the previous video. If you have a highlighter, that works really well for shading your inequalities. All right, our next example, we still don't have parentheses, so we don't have to do the very first step of distributing, but we do notice that we have some like terms on the same side of the equation. So we have a positive 5x and a negative 11x. So make sure you take that minus sign in front of the 11x term along with it. So if I combine those, I end up with a negative 6x minus 9 is greater than or equal to negative 12. Lots of negatives here in this problem. So we've gotten it back to a two-step inequality. We're going to add 9 to both sides. Bring down the negative 6x, bring down the inequality symbol, and negative 12 plus 9 is negative 3. Here, we're going to divide both sides by negative 6. And I'm going to point out here, when we move to our next step, we are going to need to put into action our special rule. We're going to have to flip the inequality symbol because we divided by a negative 6. So when we write our next step, the x comes down, but rather than bringing down the greater than or equal to, we have to switch that to less than or equal to. And then be careful again with our negatives. We have a negative 3 divided by a negative 6. The negatives are going to cancel. And also be careful. Make sure when you're dividing the fraction that you are dividing the numerator by the denominator. I think a lot of people would want to answer 2 to this problem, but this is really 1/2. We just have to reduce that fraction. So I'm going to go ahead and label the number line. And again, I'm just going to label every other here. I'm just going to go up by the whole numbers because then I can easily see that I'm graphing a fraction. We have a closed circle because it's less than or equal to. So at 1/2, halfway between 0 and 1, I'm going to fill in my circle. And then we're going to shade numbers smaller than 1/2. So 0, negative 1, negative 2, and everything in between. So we shade in that direction. So again, to reiterate, pay special attention to the flip because we divided by that negative. All right, moving on to our last example. This one has a lot going on here. The first thing we're going to do is distribute. So I'm distributing the negative 5. Now I am multiplying by a negative, but I'm not multiplying both sides by the negative number. So I'm not going to be flipping anything just yet. I'm just going to go ahead and simplify. So I bring down the 12, I bring down the less than symbol. Negative 5 times 2x is negative 10x. Be careful here. This is a negative 7. So when I take negative 5 times negative 7, we get plus 35. I know oftentimes those double negatives are overlooked. The rest of the terms are going to come down. We have a minus 2x and a positive 1. And then looking at what's remaining, we are kind of moving on to step 2 here. We've got like terms that need to be combined because they're on the same side of the inequality. So we bring down the 12, we bring down the less than, negative 10x and negative 2x is negative 12x. But we also have some like terms here with our 35 and our 1. So I'm going to go ahead and put those together right away as well. The next step, we want to try to isolate the x. So I have to get rid of the positive 36. So I'm going to subtract 36 on both sides. 12 minus 36 is negative 24, which is less than a negative 12x. Here's where it gets a little tricky. We're going to divide both sides by a negative 12. And right away, we notice that we divided by a negative. So when we write our next step, we're going to have to flip our inequality symbol. So negative 24 divided by negative 12 is positive 2. The less than symbol gets switched to a greater than symbol because we're applying our rule. And then over here, we just have x. But now the expression is not written how we like it because we are going to end up graphing this. So what we're going to do next is read this backward. We are not flipping anything because of the negative rule. We just always want our variable on the left-hand side. So now I'm going to read it backwards, and then if I read from right to left, it says x is less than 2. Now you may think that that undoes the flip that we did when we divided by the negative number, but it doesn't. I changed this less than symbol to a greater than symbol when we divided by the negative. But because the variable is on the right-hand side of the inequality and we want it on the left, we simply read it backward. So now that it's in the correct format, we can go ahead and graph. And again, I think I'll just go by 2's. A little bit less work to label. And our endpoint here is 2. It is an open circle because we're looking for numbers less than 2. It can't be equal to 2. And then we are going to shade off to the left. So to summarize, when you solve an inequality, you are going to follow the same steps that you followed when you solved equations. There are 2 things that you want to be aware of. First would be the flip when you multiply or divide by a negative number. And second would be potentially needing to read your inequalities backward if the variable is on the right-hand side. This concludes your video, and you may now move on to your practice.